Great. And so I'd like to introduce our first speaker, who is Tobias Stalder, who is a project associate in R&D at Grolemund and Partners. And he's done some interesting work on creating custom Gameboy graphics with ggplot2. So I'll just hand straight over to Tobias to begin his talk. Thanks, Tobias.
Thanks, Paul, for the introduction. And I will share my screen now. So are you with me?
Yeah, perfect.
Good. Thank you very much. So thanks for having me at Brighton R. It's really great opportunity to share this small package that I created. I'm going to begin with a disclaimer. So I wrote this package about 1 year ago, or I started with it when I was about 6 months into learning R, or programming in general. So this really shows in the code and you will see it, but maybe it's also a good point to discuss on where it should be improved or can be made more elegant. So this package that I created is called ggameboy or ggameboy. You see the pronunciation difficulties. Or what else we can do with ggplot2. So maybe that you know a bit more about who's talking. So my name is Tobias Stalder. I'm based in Switzerland, and I'm currently almost done with my master's in geography with a focus on biogeochemistry and geoprocessing. And I work since about 4 years as a data analyst at Grolemund plus Partner, which is an environmental engineering company. And as I said, my R experience is about 1.5 years. So I want to start off with how I mostly use ggplot2. And one of the fields is just research. So I see, for example, simple line plots with a smoother on the top, but also do a lot of maps with a ggplot2, like the one on the bottom, which is a map of Switzerland with the hill shades and some points and a sampling pattern from a research project, just to know for you guys where I'm coming from with the experience. I also regularly participate in Tidy Tuesday, which is a Twitter challenge from R for Data Science, where they just provide a data set every week that you can mine and analyze and visualize. And yeah, it's a really good practice for data wrangling and visualization, I think. I also got into gganimate some time ago. So what you see here are just 4 GIFs. This is really just for fun and getting into this whole animation system and wrapping my head around how data behaves, like on a time scale and on an animation scale. And yeah, so ggplot for me reaches really from scientific plots, I don't know, like bar charts, standard deviations, significance levels, whatever, but also to these really sophisticated visual designs like this one from Cedric Scherer, which I guess the people on our Twitter know him, who's really let's say a grand master of really making sophisticated visual designs with a ggplot2, like this one, which is stunning just to look at without further explaining what is shown. Yeah, so the gggameboy package came to mind, or just the idea of plotting a Game Boy in ggplot2 came to me when I saw a lot of like web developers who were sharpening their HTML, CSS skills with little challenges, like for example, plotting a Game Boy with a CSS. And I was just asking myself, can I do that in ggplot2 as well? And this was basically the incentive for getting into this. And the very short answer is, I guess, yeah, we can do that in ggplot2. So here to the right, you see my hello Brighton R Game Boy that I plotted with the hex codes of the panel that you guys showed in the promotion. And to the left, you see just this little snippet here is basically the code that is needed for this with my package. So it's just a function that is called Gameboy plot, and you can add a screen text, a case color, a background color, and here I changed the color for this little R background here, return it, and this is how it can be plotted out of my package function. And I would like to take you now on a journey through this function, which is shown here. And that's what I meant before, like it will show in the code that I was not very experienced at this point, but I decided to show the function as is, and also how I developed it at this level, because I think it's very easy to really understand how I built the Game Boy layer by layer. And I would like to start like with the input parameters. So I wanted to make the Game Boy like as customizable as possible. So here you see all parameters that can be changed. So we're starting with background. You can change the case. You can change this glass frame. You can change the screen. You can the color. The color you can change, and then you can change this screen text, but also the color for this Game Boy font here, and this little text over here. All the buttons and the speaker. So it's really offers some variety to really make your own custom Game Boy, and that was basically the idea. To the left, you always see a Game Boy where I colored what we are actually talking about right now, and the rest is either gray or black. So basically, the function starts with a really not so nice dependency of the statements package, which is a package for geospatial visualization of United States containers. But there is a neat little geom that I exported. It's called ggameboy, and it's basically a rectangle, but with rounded edges, which makes my Game Boy a little smoother around the borders. So I basically start with the case. So I'm just building this ggameboy. I'm building a case. Then I'm putting this glass frame on it here to the left with the same function. And then the window or the screen is basically just a normal geom. So you see you have here this rectangle without a smoothing edge. And next up, I'm just layering over it like different buttons. So basically, or obviously, the A and B buttons are just oversized geom points at certain locations. Start and select buttons are, again, just rectangles. And then what I want to mention here is that you saw now in this code snippets that I show you that I'm always passing like directly the numerics into this geom. So it would be more elegant to plot it out of a data frame, but for developing like the positions of all these geoms and how they behave in size and export files, etc., I really had to just try hundreds of options of decimal places in the Y and X scale. So I left it at that because I couldn't figure out just from my mind, like, I don't know, a data frame or a matrix that holds these. So I'm not, the IQ is not high enough for me in this case. And that's also why the code looks like this. So we had the case, the glass frame, the screen, and A/B button start select. And now we're coming to a point that you cannot change when you use the function. That's the power light. And I don't know if you see it, but I try to make it glow a little. so that is not really sharp. And I attempted this with just using 2 geom points. Both are red. One is just a big, a little larger and has a low alpha. I guess I could do more in that front, but that was just an attempt to give it some kind of power light feel, like with the old Game Boys. I don't know if you guys had one when you were kids or older, right? And then this steering cross are, it's very simple. It's just, again, just 2 rectangles plotted over each other. So it's just very much a make believe that I created here this own forms and whatever, but no, I just went all the simplest way that I could imagine, which is just putting 2 bars over each other. And then again, something that you cannot change is this case shading here, this white shading, which is again this GMR rect just with a very low alpha. And I just tried to make the Game Boy a little more fancy and approachable that way, instead of just having like a plain coloring. And now comes the monstrosity of the function. Like, this is what I told you guys about with the data frame. That would have been nice to plot all these geometries out of it. And this is basically just a 4x4 geom point. So I have right now an update in the pipeline that solves this. These, I don't know, 50 lines of code that could be done in one. So yeah, but this is, as I said, I'm presenting as is at the moment. Yeah, and then we have all these text elements, which I solved with just the annotate function with a text geom. And yeah, I mean, it's basically just this Game Boy, and then here comes the text that you can pass from the function parameter, the screen text, and this done in R here at the top, where you can change all the colors, and also here this little background. Of course, I mean, if you take it really to detail, what is written here is done in RStudio, which is right for me, but not right for everyone. So maybe I'm going to change that really to have this R with this swing to see that it's done in the programming language, not the IDE. Yeah, and the background of the Game Boy is just done with the theme, because I mean, basically it's a ggplot2 plot, right? So we can just change the background with this plot background element rect, and just pass fill and color from the function input, and then it takes that. And of course, we using theme void because I don't want to have any axis, fixed coordinate system, a defined x and y scale, and continuous data. And yeah, that's basically all all what this function holds. So I would say that's a pretty rough code, but in the end, when we just staple up all the layers, it doesn't look so bad. I also added this function to the package, which is just like a save Game Boy PNG, which is just a wrapper for a GG save with a fixed width and height ratio. I mean, this is not necessary. You can save it however you want. I just think that Game Boys look really nice with this export function. And since the package was done in or uses ggplot2 verbs, if you want so, we can use all the capabilities that come after ggplot2, like patchwork, for example. Like, I don't know if you know this package just to stitch different ggplot2 plots together. And for example, here I just plotted 6 different Game Boys with my package, and then with 2 or 3 lines of code in the patchwork syntax, I can just create a poster. So that's what's really cool about that. So I have a lot to do with this package. It's in a very raw form, so I didn't make a update in the last 9 months or something. So I have these dependencies. I have the state bins dependency that I want to avoid. I also have some code written that solves this problem, but it's not live yet. Have to export the pipe separately. I have some issues with the extra font, etc. So there's a lot of work to do, and also according to code structure. So I really want to just take one day and put all these numerics into a data frame and then directly plot all or plot the data directly out of a data frame instead of having 4x4 geom points to plot a speaker, right? So in conclusion, I would say yes, we can do that in ggplot2, which is was really cool. I learned a lot. So I also learned about dev tools with this package and documentation and Roxygen. And so for me, it was a really great learning experience. And also now with this Gameboy plot function, I did these Game Boys within, I don't know, 10 minutes or something. So it's really fun to, I don't know, express yourself if you have a minute to try it out, right? So I want to really thank you for the opportunity that I can present here and show my TG Game Boy package. And thank you for your attention. And yeah, hopefully we can discuss some things. And if you have something on your mind later on, you can also reach me on Twitter, and LinkedIn, and of course also on GitHub, where this package lives at the moment. So thank you very much for having me.
Thanks very much, Tobias. That's fantastic. It's just really excellent, innovative, fun work. It's really nice to see, and the level of detail that you've managed to cram into that package for customization is just fantastic. And I'm sure lots of people will have fun playing around with it and making their own Game Boys. It was good to see that you had plans to sort of refactor the code to try and make it look a bit cleaner, and presumably with the code being on GitHub, this could even be a small project that someone who hasn't really contributed to an open source project before could help with.
Yeah, of course, I'd be very open to that.
Great. Now, does anyone have any questions in the chat that they want to ask Tobias?
I've got a couple of questions, I think. No one
else?
Go
for it.
So I suppose well, two questions. First one is that out of all of those configurations, because you showed us so much and all of the code, which one did you find the most challenging? Which bit of that customization was the hardest to get right?
I mean, I think, yeah, I mean, the speaker at one part, I mean, I calculated the, I mean, it's a basic calculation, right? It's always the same distance between the points. So I calculated the matrix and the positions, but it didn't work. So I was like, and then I went to a friend of mine who's, I don't know, better at algebra than me. And I was like, what's wrong with my calculation? He was like, everything is okay. Like there was somehow, I don't know, an issue of passing these numerics and mapping them. I don't know what something under the hood of ggplot2 like really made it impossible to make this like right. So I had to really fine-tune the digits on the third decimal place or the second decimal place to really arrange this speaker. And I think this took me 4 hours or something. So this was the most challenging part in terms of the annoying part. And then what was also not difficult but challenging was just arranging everything. I mean, all the buttons and the speaker and everything onto the Game Boy that it looks right somehow. Because if you, I don't know, if you have a Game Boy on your desk, you will see that it looks quite differently when it from the arrangement of the buttons. But if I arrange them like in the correct space, it would just look very plain. So I had to optimize the optics for this output, which is not like in the original Game Boy Color. So that was a bit of a challenge to really make it look a bit cool, I think.
Yeah, no, it's amazing. My other question is, obviously you saw this and thought, can I do that in R, or can I do that in ggplot2? What's your next pet project aside from a Game Boy? What else have you looked at and thought, oh, I'm going to try and visualize one of them in R, or haven't you got any yet?
Yeah, I mean, I have a feature request in this package on GitHub where somebody said, oh, you could do a Nintendo Switch. And I was like, yeah, I mean, you could probably do that, but I mean, I think it would take me 2 days to make out of this code now, make a Nintendo Switch in the same style. But what I really wanted to do was like going 3D. And I mean, right now I'm really like have a lot of work on my shoulders, so I don't have time. But this would be the next project within this package, to make it 3D, or just giving it a set dimension, for example, and make it compatible with, I don't know, ray shader or something like that, to make a 3D model of a Game Boy in R.
Mm-hmm. Well, that'd be brilliant.
Cool. And with your experiments with ggameboy, do you think it would be possible to animate the text in the screen?
I would, with ggamate, I'm not so sure. I think, I mean, of course, it would be possible to just I don't know, take the same text and make a fixed X value for the text, and then just fading it in over time, right? Or making it float over a Y position. So that would be definitely possible. Together with the 3D attempt, I think that would go over my abilities right now. Yeah, but my experience is that if you have enough time and resources, and with resources I mean people that know better than you, then everything is possible with R so far. I think, I don't know if it's always the best tool, but it's capable of everything that I ever imagined to do. Right.
Fantastic. Are there any other questions for Tobias? No, great. Well, Tobias, thank you very much for your presentation, and we really appreciate the effort you've put into the package, because it really is awesome. So thank you very much for coming and speaking, and we'll move on now with our next talk.
Cool. Thank you very much.
Great. Now, our next speaker is Lauri Huhta, who is a DevOps consultant and data engineer at Efficode in Finland, isn't that right, Lauri?
Yes, from Finland.
Yeah.
Yes.
And Lauri has been working on creating project management dashboards using R and Shiny, and I think you're also going to cover a little bit of Jira and Python in your talk as well. So I'd like to welcome Lauri. Thank you very much for coming, and take it away.
Yeah, thanks. I'll just share my screen. Let's see. That one. Are you able to see my presentation now?
Yeah, perfect.
Yes, right. So yeah, as told, I'm gonna be talking about best practices, mostly like the pitfalls that I encountered when I started building a project management dashboard, about the data side, and also about the Shiny side of things. And before that, just a couple of words about me. So I'm Lauri Huhta. I work in Finland for a company called Efficode. So in there, I'm a data engineer slash DevOps consultant. I do both in there, and since this year, I've been working as a freelance consultant also on all kinds of data science projects. Let's go straight into it. So usually when I start to work in some project like this, like project management dashboards, usually I need to have some kind of justification from it, from the development side and also from the ops side of things. And I've gathered some of the arguments against it and some for it, and I'm trying to debunk it. And maybe if you encounter these, you can bring these points to the table yourself. So usually what I hear is that if we are already doing so good, we are finishing all the tickets on our sprints on time. So why would we need any data to guide us if we already know that everything is perfect, can't get any better than this? Also, something else that I hear is that we don't want to really be middle managing, so or micromanaging. We don't want to be middle managers. So this is a pitfall that I run into as a lot as a data engineer too, because when you find a data source, it's so easy to just dig deeper and dig deeper and deeper, and then you are having data in your hands that is actually like really personal to some people. And if you are thinking about some project releases or anything like that, it's not even really relevant. So it's important to like justify these things, that we are not actually like trying to expose anyone in the project or in the team. We want to like help the project itself. And some arguments for it, that these things are good. Even though you are doing like really good, you can see on Jira like you're well on time on your sprints and everything, but usually there's someone else in the organization that wants to see how you are doing, wants to see some of the data of the progress. So usually you have to present some kind of information to the management, and they are probably not going to go and open all the Jira projects that you have in there and see like what does it say and analyze that. So it's good to have some kind of central space for that. And about this, like if you are doing really good in your project, do you know why you are doing so good? And what if something changes? Will it get any better or worse? And so it's important to, if you are doing good, to understand what kind of changes take you there. Or even the opposite is true. Like if something is going worse, like your lead time, cycle times are really slow, then what's going on? We want to have some kind of visibility. Then for me, as I'm mainly I work as a consultant, for me, it's good to have some kind of data that I can see even to the history of the project. If it's a project that has been going on for like 5 years already, and I come in there, I want to see the highest and lowest spots. Like I want to see the pain points of the project. So it's good to have this whole process, like whole lifetime of it visualized somewhere. So something I might also hear, if you ever use Jira, they also have visualizations in there. So do I really need to reinvent the wheel? Do I really need to do it again myself? And for that, some things I touched already, like if you work in a huge organization, it's not always like just one team of information that you are interested of. When you start to get in your organization, you have tens or hundreds of projects. It's good to have some kind of centralized place where you have all your data or your visualizations, and you can then, by your own parameters, follow the track the progress of those projects. Other thing is that if you have the dashboard, you probably already collected some of the data. So you are the owner of it now. So you can bring it back. You can use it in your development, or you can maybe have data science team who wants to do some predictions, some machine learning models. You have the data there, so it's, you don't only need to use it for one purpose. Then one thing is that I said that tools like Jira or any other project management tool, they usually have some kind of built-in visualizations or statistics, but those are usually limited to the metrics that they have provided you. And in these tools, it's possible for you to create your own columns in there and like own data types in there. So if you want to utilize that in something else, it's good to have your own systems that actually can do that. The motivation for this was mainly because I'm a consultant, so I work in different kinds of companies and only months at a time. So I want to have something that I can bring with myself. So something that is like easy to set up and that I can prove the usefulness of utilizing data from day one. And if I build something like this lightweight enough already, like beforehand, and to set it up, it takes me minutes and not any effort. It's a good tool to have in your toolbox, and that brings more value in your services also. Like maybe it's not in your scope, but if I can just whip it up in a minute, why wouldn't I just do it? Like customers will of course be happy for that. Also, you can benchmark your work, and this comes to the point that I made earlier, that you can see if maybe your effort is bringing any value to the project. Like if you check the stats on the day when you come in, and a month later on you check them again, you can easily see like, do I have any effect here, or what kind of changes has happened here? So the infrastructure it kind of evolved on the way that I was developing this. So here is the first iteration of it. So I have Jira in there, and I had already built Python data collectors, so I was using those, and then store the data in a database, in this case a Postgres database, and then our Shiny application was reading the data from there. But I wanted this to be as lightweight as possible. I didn't want to be setting up any databases when I'm building this. And as I'm working with customer data, I don't really want to care about having their data on my computer or like in any of my systems. So I wanted to make a way that it's easy to just make the data vanish after I'm done with it. So I replaced the database with CSV files, and you know that those work really well when you are working with R projects. You can just make a data frame out of it, and it's really easy. But then the one aspect that I wanted to be like lightweight and quick to set up. So I wanted to just have a one click of a button that I can launch, and all this will happen. I will start getting the data, it will be processed, and my Shiny application will be up. So I made a Docker image of it and made a Docker compose file, all the entry point scripts, and now I can just write Docker compose up, and I have this dashboard of myself, and in minutes I can show some data visualizations of my customers' projects. Maybe not all of you who are in this meetup have used Shiny before, so I will just quickly run down the basic structure of a Shiny app. So there's three parts that makes a Shiny app. So there's the UI side, where you define all your UI elements. There's the server side, where's the data processing happening. You build the visualizations in there, and the logic is in the server side. Then there's the session that like wraps these together. So following this, in the simplest form, your Shiny application can look like this. You just import the Shiny library, you define the UI object there, the server object, and then you run it and pass both of these two objects in there, and that's your Shiny application in the simplest form. So let's jump into the data collection part of this project. So there's basically 3 steps that you need to consider when collecting data. Is just to build some kind of collector. And in this project, I already had a Python collector, so I was using that. So I'm not gonna spend too much time focusing on that, but also it's one of the smallest part of this project. Like it's so few lines of code that you can actually collect this data. Then you need to understand how the API that you are using handles the data. And after that, you need to process it so you can get some better insights from it. And I will dig deeper on each of these in the following slides. So let's get coding. I know I didn't forget that I'm in an R meetup, but I had this already built. So it's just a bit of Python code. I'm going to run through it just fast. So I just want to, with this slide, to show you that the data collection is like the smallest part of this project. This is 22 lines of code. It could be maybe 10. So we just iterate over all the projects that we have in there. Jira uses this JQL query language, which is kind of like SQL, but for Jira. And you set the parameters, you make a simple GET request, you save it onto a file, and iterate until you have all the data. So this is the data collection side. So if you implement this in R, it's not going to be any more code. It's just a simple small block in there. And what I want to focus on is the data that comes out of it. So what should we look for when we get our first JSONs out of an API? First question is, what creates a data entry in Jira? What makes a data entry into the database that then is served to us in the API? And there's two instances where Jira will give you a new data entry. The first one is whenever you create a new issue, a new data entry, a new row of data will be created. And the second one is anytime you update an issue, let's say you put an issue from backlog to in progress in the Kanban swimming lane, you will get a new entry of data. And here you can see important data in here, or important values that we will use for this procession is these timestamps. As we know, each ticket will be created only once, so the timestamp of creation will always be the same with the same tickets. And when we make that change, when we put a ticket from in progress to done, we will get a new timestamp. So we know that this is like the timestamp specifically for this row of data where we put the status to be done when we are finished with this ticket. And these are important for the data processing later on. So let's think of an instance that you are just starting a new project in Jira and you want to create a ticket. So on Monday, you create a ticket and automatically it goes to backlog. But no one is working on it. So we only got that one data row into the database. So on Tuesday, no one is still not working on it. So we are not getting any new data out of it. So then come Wednesday, someone goes to the Jira, he takes the ticket from backlog, puts it into in progress field, and that creates a new data into the database and we can collect it. And Thursday, he's still working on it. And on Friday, he's done with it and we will get the third entry of the data. But here comes a problem, because if we want to plot this on a graph or a bar plot, it wouldn't give us too much information, because it would look like this. We know that on the x-axis we have the time, on y-axis we have the counts of that kind of tickets. Monday we got the backlog, Wednesday we got that in progress, and Friday we got one data entry of done. So now let's say we want to ask a question like, how many open tickets did we have on Tuesday? From this visualization, we wouldn't know it because it doesn't have any data entries in there. So what we want to do in the data processing is to fill in these gaps. So we want to build visualizations that we can readily ask it the information that, okay, how many tickets we have in progress on Thursday. Even though we don't have data on that day per se, we want to be able to ask those questions. And what it would seem like in the data rows, we would fill in these gaps so we can then ask these questions from it. And why is this so important is that here's a quick visualization, kind of like what I showed you. So the timeline is on the x-axis and the count of tickets on the y-axis. So I can hover my mouse anywhere on the graph and see that on 12th of November on 2012, on this project, there was 8 closed tickets. And even though I started collecting the data today for this project, I can go back in time and see what was the situation there. And well, asking these kind of questions don't give us too much information, but we wouldn't be able to make this kind of graph without those filling in those gaps. And here's a simplified version where it comes really helpful. Like just a simple cumulative flow diagram can be, if you can read it, can be really powerful. And if you have those information for each day, it can give you a lot of information. So in the same way that the earlier graph, we have the to-do, so the backlog on top, and the in progress, work in progress in the middle, and the done ticket counts on the bottom. So in this, we can already see, okay, the line from here that we can pull that the green and the blue meet, that's going to be our approximate average cycle time, or how many tickets on average we put through. We can have it on a weekly basis or monthly basis. We can just by looking at this graph tell it. And that's why it's important to have this data in the correct form, that you can actually ask these questions. So I'm going to explain you how this data processing happens. This is like if you want to implement it into your data. So I made it in kind of like a pseudo code, or like a pseudo, just trying to simply explain it. So as we have collected data, let's say we have Jira issues table, and on this project that I used as an example, we had 3 data entries, Monday, Wednesday, and Friday. So what we want to do is we want to build a bigger, like a master data set that we actually use later on. And we build an iterator that for each day in the project, it will select some data and make a bigger data set. And here to explain, kind of like with an SQL syntax, is that for, let's say that we are sending an iterator that would be the day, the current date, and that will be Monday, Tuesday, Wednesday. It's 5 days of this project now. So on Monday, we would go into the original data set and ask it for each issue, what is the highest updated ticket, which has the highest updated value, so that which is the latest ticket relative to the date that we are feeding it. So on Monday, the Monday's ticket, that when it got created and went to the backlog, that would be it. Then we iterated, and then Tuesday, the same thing, but on Wednesday, we already had a new ticket. So now it knows that that's the latest for that. And this is how we can like fill in the history. Even though we start filling the data only today, we can go like years back. So with this iterator, we always choose the issue ID and the updated, but this Jira issues table has all the columns that we actually care of, like what is the status of it, who is working on it. So we just simply merge these together and we append them to like a bigger table. So we just fill in the history afterwards. And in code, this is again just a quick example with Python. I promise I'm going to R right after this. So just simply, you need to find the minimum date and maximum date of the project you are collecting from, all the data that you have. Then you just send them to a while loop iterator for each day, as I told you, Monday, Tuesday, Wednesday, Thursday. You would do that. And then as you select the issue key, the updated, you group by issue key and take the maximum value. So, and then you just merge it and write it into a file. So it's really simple, just 30 lines of code, and you have all the history data of the project. Now that Python is behind us, we finally get to open RStudio. And the first thing that I do, I just write a code that reads all the data that I just collected. and I see that I have almost 1 million rows of data. And now I need to visualize it. I need to build a Shiny application of it. This is quite a big amount of data because all the operations on Shiny, it happens when you open the application. So speed is the essence. Speed is the essence in here. So it's gonna even reading the almost 1 million rows of data will take some time, and you should have patience if you want to actually see some data in the web application from that amount of data. And that would look something like this, like just a huge data set from like 2012 till all the way to 2021. So let's come back to this cumulative flow diagram. If we want to build this with the data that I just read to our studio, our code would look something like this. So I want to filter a specific project out of there. Then I want to make it an interactive plot. So I would filter also the dates. Then I would do some other filtering, and then I need to group by each day and summarize it. And then I would need to count the amount of issues for each day for each status. So with that 900, it has to go through all of those 900,000 rows of data. And then only after that, we are ready to actually visualize it. We open ggplot and make all those graphs. So what I wanted to aim for with this is that if the end user opens your Shiny application and then it reads the data and then it has to do all this grouping and summarizing, it's gonna take some time. So I wanted to take all the processing out of the application. So everything, I wanted to know what kind of data sets I would need to visualize this dashboard and do it in the data pipeline. So just move it before we actually build the Shiny app. So all the visualizations that I will be using are just getting the data and heading straight to the visualization. So what we would do with this, the information that we would need to make a cumulative flow diagram is just the dates, the type status, and the count of that status for each day. So we would just calculate it beforehand rather than in the application. This afterwards, this makes a lot of sense, but it took me some time till I actually realized that why don't I just do it in the pipeline? So this counts back like so many rows of data, like this is gonna load so fast, and the visualization is not gonna have to calculate anything when it's setting up. Another solution for this pitfall is when you have one huge file, is that, well, when I first opened RStudio, of course, how I was reading the data is that I just read the data in there. And actually in the first revision, I didn't even have this inside the UI, not inside the server. I just had it on the script. So on the top layer, it just loads it. So no matter what happens, it just loads this. And that was really slow. Like it took some time for even to read. So in the pre-processing, what is crucial to do if you want like a reactive and fast enough Shiny application, you want to split the data somehow, because you are not, almost never you are, if you have many projects in there, almost never you are interested of all of them at the same time. Maybe some subset, maybe only one project at a time, but rarely all of them. So I split the files into smaller files, and a better way in Shiny to read the data is to use reactive data reading. And how that looks like is that in the server side, you create an function that then takes something from the UI. So in here we can see we are using this project drop-down box, and from there, only after that we get the input for this reactive reader, and then we read the data set that only has the data of that project. And also we don't need to we don't need to filter by the dates that come from this time range filter, because we are only reading the files, the data that are in the span of this time frame. So this made it so much faster. And then if you always just come into the application and you always open the one project, there's no reason that it would load all the data of all the projects all the time. So another pitfall that I ran into was this, like, the chicken or the egg problem. I was thinking, like, where should I create my UI elements? Because it makes sense to create them in the UI. And how that looks in Shiny is that here you simply create a box, and inside the box there's a drop-down selector for where you can select the project. You give it some data that it presents to you, which will be the unique values of the project data set, and give some defaults, and this is what you get. So this is, of course, it makes sense to create this in the UI side as you do in Shiny. But then I came into the situation where I had to create the UI elements on the server side. And this was, as I haven't created any web applications or anything, this was a concept that was, like, baffling my head for some time. So say we have this selector on the top of the application where you can just choose the project that you want to see the data from. And if you choose that, it will read the data set. And then we want to also create this time range slider here. And you see that it has the end date and the start date. But if we already have this here and we have the information when did the project actually start, we read that only after we select the project from the selector. Then how do we get it back in the UI? Because the UI has been processed before the data has been read. So a neat concept that I ran into when developing Shiny is that you can reactively create the UI elements in the server side. So in here, what happens is that after you have chosen the project of data that you are interested of, it will read the file, it will get all the relevant metadata, and then go back to this server side, and there it reads the values that you need, and here you build the slider input in the render UI function, and here you pass in the values. And this was important because if I had many projects in the same application, like I'm reading a lot of projects from Jira, some projects might be like 10 years old and some of them are only like 1 year old. So if I just take the minimum and maximum of all of those, then I can slide this slider up and down and nothing would happen because it's like out of span of the project that you are actually currently looking. And well, it works, but it's not really a good user experience. So after you, in the server side, you create the UI elements, then they will always be set the correct way. And even though this project drop-down box was created on the UI side and time range slider was created on the server side, on the front end, they just work in the same way. The user won't see any difference in them. But I think that's it for my talk. I think I'm just a bit of over time, but I think in the meetup overall, we have plenty of time left. So if you have any questions, I'm happy to answer to any of them.
Excellent, thanks, Lauri. That's a fantastic talk. And did you have any examples of the dashboard itself that you are able to show, or are there any images of it available online anywhere?
For now, I'm not really available to use because the data that I've been using has been under NDA. So it's difficult always when building these, like, because well, I would have some small data sets, but those are not really drawing anything interesting for us.
Sure. No, that's fine. Thanks very much. It was an excellent talk. And did you find any other solutions to speed up the application, like things like the DT package for handling much larger data files quickly?
Oh yeah, I was experimenting with like different. One of the method would be, there was some kind of this feather package that creates like I think it makes a binary out of it, or it makes like really easy to read. And then another one, if you cache all these data or these visualizations. But I experimented with those, but I think the biggest pain point with Shiny is when you have to process the data and actually build the visualization. So the speed up on those, if you have made the data already as easy as possible to visualize, it wasn't any significant anymore.
Sure, excellent. And does anyone else have any questions for Lauri?
I've got a quick one. So I realize this is probably a bit hard to estimate, but I was wondering if you could sort of estimate how many projects you've used it on, and if it's sort of provided a noticeable difference in how you work.
Yeah, well, this specifically, this, like, I'm using, I haven't used too many projects with it, but my main job as a data engineer, I worked with a lot of teams and built different kind of data solutions, and they of course always help. And because just as I said earlier, like if you have the understanding the things that you are doing well and what things that make you perform worse, it's always like hell. If you can read the data and if you actually then implement it to your daily work, it really speeds up.
Yeah, absolutely. Yeah, that's really cool. And is anyone else in your team using it as well?
In my company, we built this. Well, this is basically like open source, or like it's open source but not published yet. So if you are interested of this, I can release it, do some cleanup and release it. But yeah, this is like meant to be a consultant's tool that we can use it, and there's some early phases of the using already on.
Cool. I'm sure there'd be a lot of interest in that if you were able to release it. And then, of course, the R question: do you see a situation where you could replace your Python code with data wrangling in R?
Definitely. Like there's
it
nothing
looks like it looks like it fits the paradigm of tidyverse verbs for a lot of the functions.
Yeah, probably a lot of the data wrangling would be even easier to do with R, but as the infrastructure mostly on the back end, or like the data collection, was Python, and you wanted to do something on the way on that, I turned into using Python. But of course, if the data collector originally would have been R, or maybe if you had used some no code, then definitely I would have gone with R. So I even think R could have been easier in this case.
Possibly, yeah. And but it's nice to see both working in conjunction, because there's always that debate in the R and Python communities of which one's best. But in fact, they're both good at what they do, and being able to blend them could be very powerful.
Yeah, definitely. Like when I came to the data science field, I started out with R, and then well, basically the market made me change my main language to Python. There's just like more jobs, but I think most fun jobs like are made in R, like all the like research work and all the like science behind the data. It's always more fun with R, because with Python, usually you just have to think about the infrastructures behind it.
Cool. Yeah, I think we've just found the new motto for Brighton R. It's always more fun with R. Thanks for that, Lauri.
Thank you.
Do we have any other comments or questions? Well, I don't think we have any more questions. So, Lauri, thank you very much for an excellent talk. And if you do decide to open source the package, do let us know so we can have a look.
Yeah, of course, of course.